All right. 1.4, we're building functions out of functions, and I'll give you kind of a heads up on this. This is all going to be pretty straightforward, and you should recognize this from what you did last year, except for the very last thing that we're going to talk about, which is like just this kind of picky little detail about something that you already know and understand. Okay, and it's important, but it's not like a grade killer if you make a mistake on something like that. Okay, so expect this to mostly be very familiar until we get to the weird part, and then it might be a little might get a little fuzzy at that point. Okay, but we got this. We're gonna get you through it. You're gonna practice it. And we'll answer some questions on it on Thursday, I'm sure. So the first part of this is the algebraic combinations of functions. So the whole idea is here, we're going to have multiple functions. We're going to squish them together into one single function. Okay? So the algebraic ones are just the 4 operations that you've learned way back in elementary school: add, subtract, multiply, and divide. But instead of doing it with numbers, we're doing it with functions now. And these are really basic. We're going to do an example together right now. Did you guys already write this part down? By the way, I haven't done like notes where you've had to write stuff in this class this year. So please, if I'm going too fast, can you hold up a finger and say that's my signal to slow down a little bit, okay? Or give me 1 more minute so I can get this written down. Okay, give me some feedback if I start moving too quick for you. All right, let's do this. So we're going to find f plus g of x. Let's write it down. F plus g of x. Here's our 2 functions up here. When I look at this, I see, oh, they just want us to add those 2 functions together. So I'm going to set myself up for success here. And in those 2 spots, I'm going to fill in my 2 functions. One of them was 2x plus 1, and one was x minus 2. And all I need to do is simplify that, and we're done. That's it. You guys feel comfortable simplifying, combining like terms, even when there's parentheses? I think we got this. 2x and x is 3x. 1 and negative 2 gets us negative 1. That's it. If they ask us instead for f minus g of x, we're going to do the same thing. I'm just going to write my 2 functions and stick a minus sign in between it, simplify that down, and we'll have ourselves an answer. So I'm fairly confident that you guys can pull these off. Actually, I'm more than fairly confident. Go ahead and do the other 3 here. Do the subtraction, the multiplication, and the division here. I'm going to work the problems up here as well, but I would prefer that you try them yourself. Look up here if you need a hint or to check your answer, rather than just copy me down. You guys got this. if you get finished building those and you're feeling good about it, the next thing I'm going to ask you to do is to find the domain of those 4 functions that we just created. Welcome to do that now, or you can wait until we discuss that as a class. Do you guys use FOIL for this? Is that what you do in Algebra 2? You do FOIL, first outside, inside, last? Okay, good. That would be something that if you're unsure about how to go from this to this to this, make sure you see me so we can get you caught up on that. We'll be doing a lot of that this year. Anybody need a moment before we start working on domains? All right, look at that first one, 3x minus 1. What's the domain of that function, 3x minus 1? All right. So first one has a domain of negative infinity to infinity. Because there's nothing that can go wrong. We don't see any fractions. We don't see any radicals. Nothing's going to break in this thing. What about the second one, x plus 3? Same? Yeah, the domain's the same. Negative infinity and infinity. What about 2x squared minus 3x minus 2? Same thing. Negative infinity to infinity. I'm being lazy. I don't want to write it down again. How about the last one? Is there anything in this last one that could break? There is. This one has a fraction, so we should do the work and say x minus 2 is not equal to 0, x is not equal to 2, and then transfer that into interval notation. I'm hoping that finding domain for functions like that is starting to become kind of second nature for you guys. We'll get an opportunity to practice that with the review that we'll be doing on Thursday. All right, you guys feeling good about the algebraic combinations? All we're really doing is we're wrapping up the 2 functions in parentheses and slapping a plus, a minus, a multiply, or a divide in between. That's it. And then a little bit of simplifying. Okay, here comes the fun one, is composition of functions. Now I want you guys to just pay attention, set your pencils down, and pay attention to this before you start writing it down, and I promise I'll give you time here, okay? So have you guys seen this FOG thing with the little tiny O? I don't really like that style. I prefer to write it as f of g of x. This makes more sense to me, so this is how you'll see me do it. But as long as you're comfortable just transferring one into the other. So here's the big idea of what's going on. I want you to focus over here. I want you to think of this is called a composition of functions, and I want you to think of it like a factory, okay? So it's a factory and it's got some machines inside of it. We're going to load some raw materials into one side of the factory. Those materials are going to go into a series of machines. We've only got 2 here. X is going to go into the G machine first. The G machine is going to spit out something else. Okay, so maybe the G machine puts a screw into it, and it spits it out. And then that product goes into the F machine, and the F machine spits it out. And then we load it up on a truck, and it drives out of the factory. So it's just multiple functions or multiple machines inside of a bigger package. But what's important is the order that it goes through. So if we are doing f of g of x, and thinking of it as a factory, x actually goes into the g first, which kind of is counterintuitive for me. F of g of x kind of feels like it should go into the f first and the g second, because that's the way it's written. But it's not. The x would go into the g first. And what I recognize here is that the x is the thing that's kind of inside of the g, and then the g's feeding into the f. Okay. So whatever you need to write down, I'm gonna stop talking here. Pick up your pencils. Whatever you need to write down. Maybe you don't need any of any of this, if you think this would be helpful to you. I'm going to be talking a lot about this analogy of composition of functions being kind of like machines inside of a factory. The thing that's, and this is what we're on for the rest of the class today. The rest of our lesson is about composition of functions. As you're writing, I'll give you sort of a preview. We're going to talk about how we do compositions of functions and how we figure out what the output's going to be for a particular input. We're going to create shortcuts that make that process easier. And then the tricky thing that we're going to discuss at the end is going to be the domain of composite functions. And that's where things get a little bit tricky. In the analogy I was talking about a minute ago with a factory, what would the domain represent for a factory? What does the domain represent for a function? This is a concept that I hope that everybody's able to answer. I hope you're answering it in your head. What does the domain represent for a function? What is it? Why do we talk about it? It's the values that can be x, the values that can be input into the function. So if it's a factory, then the domain would be like, what raw materials are you allowed to bring into this thing? The range would be what products can we produce in this factory. But where it gets tricky is that every machine inside the factory also has its own domain and range, and that's where things get a little messy. So we'll get to all that, and like I said, that kind of gets into the weeds, a little bit of minor details at the end. The beginning stuff, though, I got great news for you. All it is just substitution. You might have to do substitution 2 or 3 times to complete a problem, but it's just substitution. Okay, anybody need a moment before we move on here? Give me the sign. We're good to go? All right. So let's do this. We're gonna do a couple examples together. So this example is actually going to take several parts, have several parts to it. And on my notes, this example is kind of like a whole piece of paper. And we're going to do sort of 4 separate things with it, and there's going to be some connections I'm going to ask you guys to make. So if you're close to the end of a piece of paper, it may be helpful to just flip to your next page so you kind of got everything together. It's up to you. Totally up to you. All right, so I'm going to give you 2 functions, and then we're going to mess around with compositions of them. So the first function's f of x equals the square root of x plus 1. And the second one's g of x, and it's x squared plus 4. And if you're not starting a new page, when you do start your new page, it might be a good idea to copy these down at the top of them until we're done with this example. So we've got sort of 4 problems we're going to address in this example. The first one, I'm going to call it part A. I'm going to ask you to find f of g of negative 2. Find thing. There we go. Find f of g of negative 2. Of g of negative 2. So if I asked you to find f of negative 2 or g of negative 2, you guys would know exactly what to do, right? What do you do with that negative 2? Put in place of all the x's. Simplify, right? F of g of negative 2 is kind of the same thing, except we've got to do it in a couple steps. When I do these, I like to look from the inside out. So negative 2 is the input. I'm going to focus my attention on this g of negative 2 thing. So for right now, I'm going to leave this f alone, and I'm going to do a little side work over here and figure out what g of negative 2 is. And we know how to do that. I'm just going to take this g function and remove my x, stick a negative 2 in there, see what output comes out. Bless you. 4 plus 4, and it ends up being 8. So then I can replace, in my original problem, I can now replace that g of negative 2 with 8, because that's what g of negative 2 is equal to. So we've substituted once. I think we got to substitute one more time. Because how are we going to find f of 8? Well, same way we usually do. We're going to take our f function, which is the square root of x plus 1. And we'll stick that 8 into there. And we'll simplify it and get our final answer. So it comes out to be 3. So if you were looking at this factory from the outside, you saw a truck roll up and load off a bunch of negative 2s in the loading bay. What are you going to see coming out the other side? We put negative 2s into this factory, we're going to get 3 coming out the other end. Now somewhere inside of there, they're making 8s also, but you wouldn't see that from the outside. You would just see the negative 2 coming in and the 3 coming out the other side. Question? This would be just positive 3. So the question, great question. Thank you for asking. Should this just be positive, or should it be positive or negative? The times that we have to worry about that whole plus or minus thing is when we have x squared equal to a number. So if I had told you that x squared is equal to 9, and then we solved that by taking a square root, because of the square, right? X could be negative 3 or positive 3 and could make that original one true. So this is where we have to do the plus or minus thing. It's awesome that you're thinking about that, because that's a very common mistake. Doesn't apply in this situation because we're not solving. Again, thank you for that question. Other questions? You think you'd be up for trying one on your own? Yeah, we'd love to. Okay, let's do part B. Let's just flip it around. Let's do g of f of negative 2. Using those same 2 functions. Give it a shot, kind of follow the same question or the same steps that we did just a second ago. Start from the inside and work your way out. Uh-oh. So we're only working on functions in the real numbers. Are we going to get an output for this thing? So we're going to say this is undefined. So f of negative 2 is undefined. So then what's that mean about f of g of negative 2? It's also undefined. What went wrong here? Say that again. We can't find the square root of negative 2? That's a great explanation. Hey, I'm going to challenge everybody right now. I'm going to ask you a question. I would like you to come up with a 1-sentence answer that contains the word domain. All right? What went wrong with this situation? When we tried to find g of f of negative 2, what went wrong? Can you answer that as a sentence and include the word domain in your sentence? You can jot it down or just kind of say it to yourself in your head. I'm going to ask you to turn to your neighbor and see what their sentence is here in a second. Yeah, why don't you guys do that? Talk it over with somebody sitting near you. How would you answer that question and use the word domain? Anybody want to be bold and share their sentence or their partner's sentence with the rest of the class? Go ahead. The domain must contain all real numbers. The square root. Wait, okay. Can you say your sentence again then? Because you changed it on me. I think you're on the right track here. Go ahead. And the square root of a negative 1 isn't a real number. Good. Although I'm gonna challenge you. I think this is more of an output than an input. So I think you're kind of talking more about range actually, which is awesome. We're gonna do a whole bunch of that when we get into inverses in a bit. How about another sentence? Go ahead. Does it? Does the domain contain all real numbers? That's a good question. Does the domain for this function contain all real numbers? I can say it definitely doesn't contain negative 2 because we didn't get an output. The domain does not contain all real numbers. So someone give me another sentence. Be specific. Yes. Why didn't it work? Negative 2 is not in the domain. That's why it didn't work. Negative 2 is not part of the domain. We tried to put something in, the machine broke. So what do I know? I don't know what the domain is right now, but I know negative 2 is definitely not in there because it did not give me an output. That's awesome. Thank you guys, all of you, for your input, because I think we've exposed some kind of common misconceptions about what domain is. Domain is what you're allowed to put in. We have just proven that negative 2 is not part of the domain because it didn't work. Awesome. Okay. Let's do part C now. In part C, I'm going to ask you to find f of g of x and its domain. And before we get started on this, I got a question. I want you to make some connections because there's a really important connection coming up here in a moment. How does this connect back to part A? What's similar and what's different from what we're about to do here and what the question's asking and what they asked us to do in part A? Aside from the domain part. How is this different? Anybody want to be bold? What's different about the question? Yes, yeah, exactly. In A, they're asking us to find the output when we have a specific number, negative 2. We're still going to find kind of something about the output, but we're not going to get a specific answer for this, are we? When we work this out, because we don't have any numbers to use. So we can't get a specific output. So what are we actually going to be doing when we do this? Well, the way I see it is what we're going to make here is a shortcut that would allow us to do this process that we did up here faster because we'll be able to do it in one step instead of two, is essentially what we're going to do. Okay, we're gonna make ourselves a new function that's going to describe the whole factory. Instead of just knowing what individual pieces are in there, it's going to describe what happens when you take an input into the whole factory and output it. And then we wouldn't need to know what these individual machines do in order to do this process. Okay, so we're doing the same thing, but we're doing it more generally. So we're going to follow the same steps though. Same idea. We're going to start from the inside. And we're going to just kind of replace stuff as we go. So I can't replace x with anything because they didn't give us any numbers, but I could replace g of x with something. What do we know that g of x is equal to? Scrolling back up to the top of my page here. G of x is x squared plus 4. So I'm just going to replace g of x with what it is. So we're just substituting the equation for g of x in. And then to wrap this up, we just need to, well, we need to do f of this. Okay, so we're going to need to take this x squared plus 4 and plug it into our f function. So let me write out my f function. The f function was the square root of x plus 1. All right, and then let's simplify that out a little bit. So we got x squared plus 5. Is that what you guys came up with? Sweet. I'm going to write out the whole thing. F of g of x is equal to okay. So we did not get a numerical answer, but what do we have now? What we have now is a shortcut. If they ever ask me to go back and do part A again, in fact, I'm going to do it right now off to the side here. If somebody asks me to do f of g of negative 2, I'm not going to do it the same way we did it a moment ago. What am I going to do with the negative 2 now that we've got this shortcut? We just plug it right into this. And that'll give us our answer in one step instead of two. So I can just take this new function that I created, plug that negative 2 into there. Negative 2 squared is 4, plus 5 is 9, so we're doing the square root of 9. And our output comes out to be 3, which is exactly what we got a moment ago when we did it in multiple steps before. But the nice thing is that this works for any input. Anything that I put into this will give me the output for it. So all right, let's talk about the domain of this thing. They did ask us to find the domain. So how are we going to find the domain for this? Do we have to worry about it, or is it all real numbers? Is there anything that could break in this equation? Yes, it has a square root. So let's do our restriction, x squared. So we're doing our domain work here. X squared plus 5 must be, what's the rule for the radicand? Greater than or equal to 0. And then we're going to solve this and find what values of x make that true, and that'll be our domain. What values of x make that true? Is 0 going to make that true? If you plug 0 in, is it going to work? 0 squared plus 5 would be 5. Is 5 greater than 0? Yep, 0 works. What if I put some positive numbers in? If I take a positive number and square it and add 5, is that always going to be bigger than 0? Yes. What if I put negative numbers in for x? If I take a negative number and square it, and then add 5 on top, is that always going to be greater than or equal to 0? Yeah, because when we square that negative number, it's going to turn it positive. Then we're adding another positive number on. I think this has the solution to this is everything. We used a tool when we were doing this previously. We went ahead and sketched what the graph of y equals x squared plus 5 looks like. What would that graph look like? What's the shape of it? It's a parabola opening up or down. Where's our y-intercept? At 5. So it's going to start here at 5 on the y-axis and open upwards. Can you see visually that every x value is going to make this thing above 0? It's going to make it above the x-axis. So the solution to this is everything, all real numbers. We're going to write it in interval notation, negative infinity to infinity. That means that I can put any input I want into this factory. I'm going to get an output. All right, we got one last part here. D. We're just going to reverse it. We're going to do g of f of x. Were there any questions about C before we move on? Actually, I want to backtrack for a second here. Could I get you guys to look at this? This is what we came up with, x squared plus 5. Was anybody tempted to reduce and cancel this square with the radical? It's okay if you were. It's a very common mistake. Let's learn from it. A lot of times people think that I can split this up and make this the square root of x squared plus the square root of 5. Are you allowed to do that with a radical? No. No. Not if you have addition or subtraction in here. Now, if it had been x squared times 5, then I could do 2 separate square roots times each other. And then I would have been able to simplify this square root of x squared. Okay, but that's where we'd have to go back and look at that plus or minus thing that you asked about earlier. So there's nothing we can do to simplify that. Okay, let's do this. Okay, g of f of x. This is where things are going to get a little wacky. I like this one. So same thing that we did before. Let's just start substituting some stuff in. F of x, it's not on my screen, but I can see it further up my page. F of x is the square root of x plus 1. And then I just need to do my g function to that. The g function is x squared plus 4. So we leave the x squared out and put that x plus 1 in there. Square root of x plus 1. Now there, we've got a square root and a square. Those should cancel. And they do. That gives us x plus 1 plus 4. So what's our final shortcut? What is g of f of x? It's x plus 5. Awesome. Are you guys feeling pretty good about doing the substitution, simplifying and everything? All right, are you ready for it to get wacky though? What's the domain of g of f of x? What's the domain of x plus 5? It's everything, right? Negative infinity to infinity? Well, that's problematic, guys. Why is that problematic? I think we have proven already on the same page that that is not correct. Good. What part are you looking at? A, B, C? You're looking at part B. In B, we were looking at g of f, right? We tried to put negative 2 in there and it didn't work, which told us what? That negative 2 was not part of the domain. I know for a fact that negative 2 is not part of the domain of this because we tried it and we broke the machine. Okay, so how is it possible that the thing has a domain all real numbers? Well, it doesn't actually. So I told you there's going to be like one little picky thing that we're going to add on at the end, and I'm going to show you that right now. We're going to do just a couple quick examples, and then we'll call it a day. So if you're feeling good about doing this substitution piece, that's the main thing right now, okay? I don't want, this next part gets a little bit in the weeds. I don't want you to walk out of here feeling like you don't understand everything that we did today. All right, so here's the big thing. There's an extra rule that we have to add on to this to make it work, but we got this. So here it is. And you're going to want to get this into your notes for sure. So the rule is that the domain of f of g of x only includes values that are also in the domain of g of x. So when I think about our analogy of a factory where we've got multiple machines inside and those machines are kind of stuck to one another, so parts are going into one machine coming out and then that result is going into another machine. To me, this rule means that you can't put anything into the factory that's going to break any of the machines inside, basically. So if one of our machines can't handle, I don't know, steel, then we can't bring any steel into the factory at all. So this is going to be one little thing that we're going to try and remember to do at the end of one of these problems. And it's the thing that we always forget, or at least me. I hate that when there's like, oh, there's also this one little thing you got to remember to do at the end of the problem. Like, I always forget about it. My strategy is to try and do it at the beginning, or at least write myself a note, don't forget to do this at the end, because I'm always like, oh, I'm finished with the problem, and I move on. So, and there's a lot of times that this doesn't even cause any issues. So we're going to do 2 examples here. I'm going to give you some new functions, and we'll kind of work it from beginning to end, going through the whole process. So here's our first one. Let's do f of x is 2x squared. And g of x is the square root of x plus 2. And we're going to find f of g of x. So we're going to go through the same process that we did just a minute ago. We're going to figure out what the equation for f of g of x is. And then we'll find the domain of that. But what we have to remember to do at the end is come back and check and make sure that that domain only includes things that are allowed to go into g of x. So we're going to have to look at the domain of g of x individually as well. I don't trust myself to remember to do that at the end, so I'm going to go ahead and do it now. Let's find the domain of g of x so that we've got it ready so that when we get to the end, we can compare. So go ahead and do whatever work you need to do to find me a domain for g of x at this point. That could be a lot of steps. If you can do some of those steps in your head, that's fine. I'm not going to show all my steps. I'm just going to jump to my answer. All right, were we successful there? All right, let's go ahead and do the substitution piece. So let's work out what f of g of x is. So f of, let's replace g of x with what it is. It is square root of x plus 2. And then you're going to take that square root of x plus 2 and you're going to plug it into something else. So go ahead and do that substitution. We're plugging it into the f function because that's what's going on out here. The f function was 2x squared. Substituting in x square root of x plus 2 and simplifying. Feeling good about the 2x plus 4? All right, so the last thing we have to remember to do, so that's our answer. That is f of g of x, but we need to stop and ask ourselves, does the domain of this include anything that's not allowed to go into this? And I'd say yes, it does. There's stuff that we can put anything we want into 2x plus 4. But we have to remember that the first machine that our inputs are going to see when they get into this factory is g of x. And g of x can only take values that are greater than or equal to -2. So we're going to have to actually limit the domain on this. So what we usually do is write comma and then put a domain restriction after it, which would just say x is greater than or equal to -2. So what we have found is that if we want a shortcut for f of g of x, we can use 2x plus 4 as long as x is greater than or equal to -2. Otherwise, we can't use this shortcut. Otherwise, it doesn't work. It's undefined. Okay, so that's it. Bunch of substitution, trying to remember to do something at the very end. Let's do one more. Any questions about this one? All right, last one of the day. F of x is x squared minus 3. And g of x is 1 over x plus 1. And just like before, we're going to find f of g of x. All right. So I'm going to leave this one to you guys. I would love for you to work through, ask me some questions if you come across anything that you're not sure, and then we'll come back together in a couple of minutes and compare notes. Remember, at some point, you're going to need to know what the domain of g of x is. Whether you go ahead and find that now to help remind you to use it later on, or if you want to just wait until the end to do it, that's fine. But at some point, you will need to find the domain for that inner function for the g of x piece. get caught up to you here. It is the same. Sometimes we want a different form. So substitute in my g of x, that's 1 over x plus 1. And then the f function says that I need to square 1 over x plus 1. And when we do that, we're actually squaring the numerator and the denominator. So that's 1 over x plus 1 squared. And we were just discussing whether this would be a more simplified version or if I actually multiplied x plus 1 squared out. Do you guys know what you would get if you were to multiply out x plus 1 squared? We know that it's not x squared plus 1, right? Oh, it's gonna, yes! Oh, that's so good. If you knew that was x squared plus 2x plus 1, that is going to save you so much headache in this class. That's awesome. I just left it like this. I'm going to say that's my final answer. F of g of x is equal to that. Oh, wait, but there's this other thing we have to do. We have to make sure that there's nothing that I'm allowed to put into this that can't go into this. So we need to look at the domain of this thing first. Yes? What about, oh, there's a minus 3 at the end. My bad. Thank you. Minus 3. I totally left that off. Thank you. Thank you. Copy error. Hate those things. All right, we got to look at this thing. Did you guys already find your domain for g of x? The domain for g of x is basically x can't be negative 1, right? Anything except for negative 1 works. Do we need to eliminate negative 1 from this? What's the domain of this thing? Was negative 1 allowed to go into this one? I would say that the domain for this already matches this. So there's no extra restriction that I need to place onto this, because when I look at this thing and I think about its domain, the domain for this thing would be x can't be negative 1. That's the only thing, negative 1 is the only thing that's going to break this function. Everything else would be just fine. Do you guys see why negative 1 would break this thing? We could go through the steps and set this not equal to 0 and solve it, but we're going to get x equals not equal to negative 1. So in this case, I didn't actually need this because that extra restriction was already part of the domain of my answer. The reason that we had to add something extra in on this was when I got my answer, the domain included more stuff than my innermost function did. So I had to limit this to only what could go into the innermost function. And this one we didn't need to worry about that because the domain includes the exact same stuff as my innermost function. So we're good. We're good. So we can just stick with this. All right, that's the last of it. You guys feeling okay about? So show me on your thumb meters, how are you feeling about, we'll go back to the beginning here. If I give you a couple functions and I ask you to add, subtract, or multiply, and divide them, are we like good on those? Put them in parentheses, stick a plus, minus, divide, or multiply in between them, and simplify? How about just taking a couple functions, and if I ask you to do like f of g of a number, f of g of 10, it's just a bunch of substitution. You're just substituting again and again and again until you get it to a single number. And then what about when we do it in a more general format? Are you guys feeling okay? This year's just substituting stuff in. Now some of the algebra gets a little bit trickier. The last, if you're feeling okay about all of that stuff, this last thing is just a very, very picky detail that says we got to take a moment when we finish that last type of problem and take a look at the domains. So, okay. You're going to have a problem on your test where this will come into play. And if you forget to do this, it's not going to be the end of the world. 8-point problem, you might miss a point. That's still a good grade. All right. Okay, we got some time for assignment. I'll put it up on the screen here. Give me just a moment.